Okay, let's talk about the invisible battlegrounds of the internet. Because every time you log into an app, or you buy something, or you post something online, you're stepping into what's basically a digital fortress. A fortress that's built to protect your data. But, just like any fortress, it's got weaknesses.
So let me ask you this. Think about all the apps you use every single day. Your banking app, your social media, your shopping accounts. What's the one thing that really ties them all together? Yep, you guessed it. They're all fortresses, designed to keep your private information safe and sound. But here's the thing. Attackers are out there 24/7, just poking and prodding at the walls, looking for any little crack to get inside. So today, we're going to look at how they do it, and way more importantly, how we can stop them.
All right, so here's our game plan. First, we'll get a handle on what our fortress is. Then, we'll dive into 3 of the most common ways attackers try to get in: tricking the guards, using a stolen key, and just finding doors that were left unlocked. And then, we'll wrap it all up by talking about how to build some really strong walls. So, let's set the scene. Every single web application out there is a constant target. I mean, attackers are just relentless, always looking for vulnerabilities to exploit so they can get their hands on sensitive data. Understanding how they think and what they're looking for, well, that's step 1 in building a rock-solid defense. All right, first up, let's talk about pure deception. This is where an attacker doesn't try to smash down the door. Now, they're much cleverer than that. They fooled the system's automated guards into just letting them waltz right in, or even tricking them into handing over the keys to the kingdom. The first trick in the book is called SQL Injection. Now, imagine your database is like the castle's archivist, the person who guards all the secret records. An attacker uses a login form or a search bar to pass a deceptively worded note to that archivist, tricking them into revealing stuff they absolutely should not be sharing. And check this out. This is a classic example of how it works. An attacker just types this little phrase into a password field. The code behind the scenes is basically asked, is the password correct? Or does 1 equal 1? And since 1 always equals 1, the whole thing is true. And boom, the system just lets them in. No password needed. It's crazy. So what's the real problem here? Well, it's blind trust. The fortress guards just believe anything they're told. The fix? You have to teach those guards to be skeptical. You have to validate and inspect every single piece of information coming from the outside world before you act on it. Okay, the next trick is called cross-site scripting, or XSS. Now, this one is like an attacker leaving a cursed scroll on a public notice board. Think like a comment section on a website. When some other unsuspecting person comes along and reads that comment, a malicious script secretly runs in their browser and steals their digital keys, the session tokens that keep them logged in. You see the pattern, right? The core issue is just displaying content from one user to another without ever checking to see if it's safe. The defense is to sanitize every message. Basically, you scrub it clean of any potentially dangerous code before you put it on display for everyone else to see. Now we're shifting gears a little. We're moving away from trickery and into the realm of impersonation. See, these attacks aren't about fooling the system with some bit of clever code. No, they're about exploiting trust and making the app think a malicious request is actually coming from a legit, logged-in user. First up, we have cross-site request forgery. This is sneaky. It's like an attacker forges a royal decree, and then they trick you, a trusted noble, into presenting it to the king, the web app, without you even knowing you did it. The app sees the request coming from you, a trusted source, and just does it. Things like changing your password or transferring money. The big weakness here is that the fortress just assumes that because you're logged in, every single request your browser sends must be something you wanted to do. The fix is to attach a secret, one-time use code. It's called a token to every important action. That way, the app can prove it was really you who kicks things off. Next up is broken authentication. And this one, well, it's pretty much what it sounds like. It's like having really weak locks on the castle doors or using keys that are super easy to copy. It allows attackers to do things like guess passwords, hijack sessions, and basically just walk right in the front door. Now, this next one is, wow, it's so simple, it's kind of scary. It's called an insecure direct object reference, or IDOR. Just imagine every room in the castle is numbered. With an IDOR flaw, the guards will take you to whatever room number you ask for without ever stopping to check if you're actually allowed to be there. So, for example, when you go to your profile page, you might see a URL that looks something like this, with your user ID sitting right there in plain sight, number 101. It's a direct link to your personal data. An attacker sees this and thinks, I wonder, what happens if I just change that number? So they switch it from 101 to 102, and if the application doesn't have the right security checks in place, boom, it just obediently serves up user 102's private profile. It's that simple, and it happens way more often than you'd think. Sometimes attackers don't even need to be all that clever. They don't need tricks or stolen keys. Sometimes they win because the people who built the fortress just left a door unlocked or a window wide open. This whole section is about bad maintenance and simple preventable mistakes. And these are some of the biggest, most common offenders. Security misconfiguration, that's like leaving the default admin password as password123. Using vulnerable components, that's like building your castle walls with crumbling old bricks because you never bothered to update your software. And sensitive data exposure, well, that's just leaving treasure chests full of unencrypted credit card numbers and passwords sitting out in the open. Okay. We've seen all the scary ways attackers can get in. So the big question is, how do we actually stop them? Well, that brings us to our defense strategy. It's all about building strong walls right from the very beginning. This right here is basically the security playbook for anyone building one of these digital fortresses. It really sums up everything we've talked about. You got to validate all your inputs to stop the trickery. You need strict access controls to stop impersonation. Keep your software updated so your walls don't crumble. Encrypt your data, harden your configurations, and last but not least, you have to watch the walls by logging and monitoring for anything suspicious. And that really brings us to the most important point of all. Building a fortress isn't a one-and-done kind of job, not at all. Security is a process. It's this continuous cycle of testing and updating and monitoring because the threats out there are always changing, and so our defenses have to change right along with them. And that's really what this is all about. As our source material puts it, knowledge is really the foundation of a good defense. When developers and engineers understand how these attacks actually work, they have the power to build safer, stronger digital spaces for every single one of us. So I'll leave you with this to think about. In a world where our digital fortresses are getting more and more complex every single day, is the job of defending them ever really finished? It's a tough question, but one worth asking. Thanks for tuning in.